Neutralization reactions. A neutralization is a reaction between an acid and a base. It produces salt and water. For example, HCl, which is an acid, reacts with NaOH, which is a base. You produce the salt, NaCl, and water. Salt is a generic term. It's just a compound that consists of the anion from the acid, so the negative portion from the acid, and the cation from the base. Sometimes acids and bases react in a 1-to-1 mole ratio. Sometimes the ratio may be 1-to-2 or 2-to-1. For example, if I have the acid H2SO4 reacting with KOH, I will get a salt, which is K2SO4, based on the charges, and water. If I go back and balance this, it's 1 mole of acid for every 2 moles of base, KOH. The equivalence point occurs when I have equal number of moles of hydrogen to hydroxide. So let's look at a couple examples to get to the equivalence point. The first thing I need to do is come up with a balanced chemical equation. I have potassium hydroxide reacting with phosphoric acid, which is H3PO4. I'm going to get a salt, which is K with PO4. K is a +1, PO4 is a -3, so K3PO4 plus water. I need to go back and balance that equation. I have 1.56 moles of phosphoric. I want to know how many moles of potassium hydroxide. So once I have the balanced equation, I start with the 1.56. I'm already in moles, so I'm going to do the mole-to-mole ratio. There's 1 mole of H3PO4 for every 3 moles of KOH. So the amount of potassium hydroxide to neutralize, 4.68 moles of the base are needed to neutralize the acid. Let's look at one more example here of a neutralization. Sodium hydroxide, the base, reacts with nitric acid. Nitric acid is HNO3. I'm going to get a salt, sodium with NO3. Sodium's +1, NO3 is a -1, and then you get water. It's already balanced. I have 0.2 moles of nitric, so I'll start there. 0.2 moles of HNO3. I want to find the moles of sodium hydroxide. Mole-to-mole ratio is 1 mole of HNO3 for every 1 mole of sodium hydroxide from the balanced equation. And so this would require, obviously, 0.2 moles of the base to neutralize. So in a neutralization reaction, you add a measured volume of acid to an unknown concentration, then you add the indicator to the solution. We're going to use phenolphthalein for our neutralization reactions, and then we're going to add the base until the indicator just barely changes color. That's a neutralization reaction. Sometimes they are called titrations, which is this process of neutralizing an acid with a base. The standard solution is the solution we know. That's the solution of known concentration, and the end point is the point at which the indicator, phenolphthalein, changes color. The end point and the equivalence point should be identical in a reaction. So let's look at a couple neutralization/titration reactions. Here we have HCl neutralizing NaOH. Write a balanced chemical equation. HCl plus NaOH forms a salt and water. we're going to go back to the molarity equation. Molarity is equal to moles divided by liter. I have two numbers for NaOH, so that's where I'm going to start. If I know the concentration of NaOH and I know the volume of NaOH, I can find the moles of NaOH simply by taking, go back to my molarity equation, molarity times volume. So the concentration for NaOH is 1 molar. The volume, 0.025 liters. So the moles of NaOH, 0.025 moles. That's the first step. Once I have the moles of NaOH, we can do a mole-to-mole ratio based on the balanced chemical equation, and I can solve for HCl. Balanced chemical equation, there's 1 mole of NaOH for every 1 mole of HCl. And so that would leave me with 0.025 moles of HCl. I know the concentration of HCl. I'm looking for the volume. If I go back to this equation up here, my molarity equation, if I want to find the volume, I'm going to take the moles divided by the molarity. So take the moles of HCl divided by the concentration, 0.45 molar, and that's going to give me the liters of the HCl. So 0.056 liters of the HCl. It's kind of a 3-step problem. We're going to find moles first, then do your mole-to-mole ratio, and then divide by molarity to get the volume. Let's look at one more example. This time we're taking H3PO4, reacting that with NaOH. My salt is Na with PO4, and because of the charges, Na is a +1, PO4 is a -3, Na3PO4 plus water. It needs to be balanced. 3 NaOH, 3 water. Wherever I have 2 numbers, that's where I start. So I'm going to start with NaOH. I'm going to find the moles of NaOH by taking the concentration, 0.15 molar, multiplying by the volume, 0.0385 liters. So 0.058 moles of the base, NaOH. First step. Second step, take the moles of the base, do a mole-to-mole ratio, go back to the balanced chemical equation. There are 3 moles of NaOH for every 1 mole of H3PO4. So the moles of H3PO4 comes out to 0.0019 moles. I want to find the concentration. Well, molarity is equal to moles divided by liters. So take the moles, divide by the volume, which is 15 mils, so 0.015 liters. That will give me the concentration of the acid. So 0.128 molar is the concentration of that acid. So those are some neutralization reactions. I'm going to skip the last one because it's very similar to the previous 2.